Hello, dear students. I hope you all have seen video 1 and understood the various formulae that we defined to find out correlation coefficient pertaining to our third unit of the paper Statistics for Engineers. In this particular video, we shall first recall the three formulae that we learned, and then we shall apply them in certain problems, and certain more problems would be given to you for practice sessions. So let's first recall the three formulae, starting with the direct method, where if we are given two variables x and y, this is the formula to calculate the correlation coefficient. And if there is an actual mean method that is required to be found, we calculate the deviations of x and y from the actual mean that we calculate. The mean of x, the mean of y represented by x bar and y bar. We first calculate that, then take the deviations of x and y, we call them small x and small y, and then declare the formula for correlation coefficient this way. If the actual mean is not considered and the assumed mean is considered, then we have taken the notation as dx, where a and b here are assumed mean of x and y. So this is chosen to be any value of x and y, and we have taken deviations of x and y, called it dx dy, and this is the formula pertaining to calculating the correlation coefficient for this case. But we also recall that if we have found a scaling factor as h along the x values and k for the y values, then we also said you could take dx as x minus a divided by h and dy to be y minus b divided by k, and use the same formula to evaluate the correlation coefficient, because the correlation coefficient is independent of the change of any origin like a or b that we have chosen, or the scale which we have taken here to be h and k. So irrespective of what a, b, h or k is, the answer for rho shall be the same. So let's attempt a few problems based on these three methods in the next slide. So let's take up problem number 1, where we are asked to calculate Karl Pearson's correlation coefficient for this given data. So we are given the roll number of a student, marks in accountancy, and marks in statistics. So when we are trying to find the correlation coefficient, it's obvious that we are trying to find the correlation between the marks in the two subjects, accountancy and statistics. The roll number of a student does not play any important role, and therefore we shall start constructing the table by taking the marks in accountancy as x and marks in statistics by y. Note that there are totally 5 data points given to you. So your n value here is 5. We are using here for the first problem direct method. You could also use the other two methods and check the answers. That could be a good practice. So x values are given, y values are given. We have calculated the total by adding all the x values. It gives you sigma x. Calculate all the y values, addition of all of them gives you sigma y. Then because the direct method requires just x square, y square and the product xy, we have taken the squares of x values, y values, calculated their totals as sigma x square, sigma y square, multiplied the x and y values to collect these terms, and then adding them along the column gives us sigma xy, thereby getting all these summation values which are required. Now n value being 5, all the data values are available. It's only now substitution in the formula. So as we see here, the formula for rho that we defined for direct method is this. So we have now substituted the value of n, the value of sigma xy, the values of sigma x, sigma y, then n into the values of sigma x square, and sigma x the whole square, as we said, it is the square of sigma x. Since sigma x is 170, sigma x the whole square becomes 170 the whole square, multiplied by the square root of, kindly note the square roots, it's n into, that is 5 into sigma y square, the value that we have found, and then we have squared sigma y, that is 175 whole square, and on simplifying using our calculators, we get the correlation coefficient between the marks in accountancy and statistics turns out to be 0.4286 here. Kindly note that the numerical values for correlation coefficient must always lie between -1 and +1. So our range here is -1 to 1. I'm sure you all recall that. So here it is 0.4286, which certainly belongs to the range, and that's the value of rho for this particular problem. So we have used the direct method. You could also try out getting the same value of rho by using the assumed mean method or the actual mean method and obtain the same value of rho. Let's now look into the second problem. Now the second problem reads, using actual mean method. So the name of the method is specified. So we are supposed to stick to the method. Find the correlation coefficient between the marks in economics and marks in statistics obtained by 10 students of a class given the following data. So we are given the marks for 10 students here, and the method that we are using is actual mean method. That's the second method that we are using. So where should we start from is to find out the actual mean of x and y, and we know by averages x bar is nothing but sigma x by n. So we have added all the values of x divided by 10, so that gives me 32. Y bar, adding up all the values of y dividing by n, that gives me 38. So we have now calculated x bar, y bar, and if you recall, we have we'll need to construct tables like this now. Redo a different new variable as small x, where we take up the deviations of x from x bar, and y, which is deviations of capital Y minus y bar, and thereby proceed with the values of small x and small y. Let's see that in our next slide. So as I told you, capital X and capital Y values are given to us, and we have defined a new variable small x as the deviation of capital X from x bar. X bar we calculated it as 32. Y, which is small y, we have defined it as deviations from the mean of y, which is 38. Then we continue with a similar formula. We square the values of x and write it as x square, square the values of y, write it as y square, multiply x and y, and to get us the product xy. So we have done that here for all the 10 data points, and we find we are interested only in sigma x squared, sigma y squared, sigma xy, and so the formula of rho used for the actual mean method is this. So I substitute the values. You see that on simplifying, you get the correlation coefficient to be negative here, which is minus 0.3939. It could also be rounded off to 2 decimals or 3 decimals, depending on the requirement in the problem. But in general, we declare the result to 4 decimal places. Let's look at the next problem. Seeing the third problem, it says calculate again Karl Pearson's coefficient of correlation for this data. Now, when we closely look at the data, we have something common. If you look at the x values, they are all equally spaced. I'm sure you all agree. So you see that there is a difference of 100 here. So there is a difference of 100 between successive values. And here also, there is something that is common. I don't say they are equally spaced, but certainly there is a 10 that is common everywhere. 30 is 3 into 10. This is 3 into 10. This is 5 into 10, this is 6 into 10, this is 8 into 10, and this is 10 into 10, this is 11 into 10, and this is 13 into 10. So there is a scaling factor which is 10 that can be taken. So I'm going to take that as k and h to be 100, so that I can use the assumed mean method. We have now calculated, taken the value of a to be 400 here. So if you see, I have chosen it to be 400, but you could do the same problem by taking 300, 500, 700, any number in that x. H is commonly 100, so we fix that as 100. B value, I have taken it to be 60 here. but you could also take it to be any other value to just confirm your results. And k value, because we have a common scaling factor 10 there, so I've taken k to be 10. Thereby, the bigger values, the number of values that you're given, which are equally high in quantity, they are now simplified by this assumption. So in the assumed mean method, we have now taken dx to be x minus a divided by h, and dy to be y minus b divided by k, and I have now simplified it. So dx is x minus a is 400, h is 100, dy is y minus b is 60, and k is 10. So you see the values are simplified drastically, which is now easier to handle. So now we are going to take the square of dx, square of dy, and you multiply dx dy, thereby get all the summation values, the tabular values, and now we are ready for the direct substitution in the formula. So let's see the formula in my next slide. So we substitute the values, all the values in the given in the formula. So n is 7 here, the sigma dx dy, sigma dx is 0, so it simplifies, it gives you a little simplified expression, and thereby giving us rho almost closer to 1, but not exactly 1. So it's of the form 0.9972. So here in this problem, we have used the assumed mean method by taking a value of a, taking the value of h, taking the value of b, and taking the value of k. So we have taken h to be 100, k to be 10. A and b can be chosen to be any value, so you could try out as a homework by taking up any other values, but ensuring that you get a similar row. So now let's look at one more problem which is slightly different from these three methods which were direct applications. Let's read question number 4. The following table gives the distribution of items according to size groups. Find the correlation coefficient between the size and the defective quality. So let's look at the table given to us. A size group is given, that is, the items are varying from 15 to 16, whatever the units are, 16 to 17, 17 to 18, so they are given in class intervals. And we see that total number of items that are existing in the size group of 15 to 16 is 200, out of which there are 150 items which are defective. Similarly, in the size group of 16 to 17, out of 270 items, we have 162 items that are defective. So this is how we read this table. Now we are asked to find the correlation coefficient between the size, that is this row, and the defective quality. So the number of defectives. But if you note carefully, that one is the size group is given in terms of a class interval. So the class interval, this is the lower class and this is the upper class. So you are varying from 15 to 16, that's the size group. So when I want to have one particular number for that x, if I represent x to denote the size group, then x should assume one value. So since it's given in the form of a class interval, what we shall do is take the mid value of that size. So how do we calculate the mid value of a class interval? Is just the upper limit plus the lower limit divided by 2. So you're taking the average of 15 and 16, meaning it is 15 plus 16 by 2, which will be 15.5. Thereby, you can calculate the size group, which is x, by taking the midpoints of mid values of all the class intervals. So we are now calculating for 15 to 16, it's 15.5, 16 to 17, it is 16.5, 17 to 18, 17.5, and so on 20.5 finally between 20 and 21. So we have now defined the value of x, which represents the size as a common value, not as an interval. So we have one particular value for every group. Now coming to the second part, he says you're talking about the second variable is the defective quality. Now, total number of items that I have in this size group 15 to 16 is 200. But 16 to 17, it is 270. 17 to 18, it is 340. So you see, there is a variation from every size. So therefore, if we do not have a common number of items, I cannot differentiate between the number of defective items. I can't take them as 150, 162 and call that variable as y. That would not be correct, because the number of items are variables. They are all varying. But you need to have that constant in order to declare the number of defective items. So what we shall do here is construct y as the percentage. Now this y, we will declare it as the percentage of defective items. So though they are mentioned for an overall number as 200, you calculate it out of 100 for every group, so that there is a commonality that is followed. Meaning that if there are 200 items, then 150 of them are defective. So if there are 100 items, how many will be defective? 150 divided by 200 into 100. So what will that match up to? So that becomes 150 by 2, which will be 75. So like this, you calculate the percentage of the defective items. So what is the next one? It is 170 and you have out of 162 out of 270. So what is the percentage? 162 divided by 270 into 100, which will give you 60. Then 170 divided by 340 into 100, which will give you 50. 180 divided by 360 into 100, it will give you 50. So likewise, now your variables are x, which is the size, which is assumed to be the mid value of the class intervals, and y, which is the number of defective items, which you are calculating for 100. So that assuming the total number of items is 100, in the proportional way, instead of considering 200, 270, etc., you take it as a common 100 and rewrite y as the percentage of defective items, and then proceed either using the direct method, assumed mean method, or the actual mean method, and get the result. Now here we have used the assumed mean method. So I have taken my capital A to be 17.5, h and k I have not considered, and your B here is 50, because we do not have a common scaling factor. And then we have taken dx square, dy square, dx dy, and we have now applied it in the formula to get the value of rho. So this problem is slightly different from the other three, which were exactly straightforward. So here to note here is, when I'm asking you as to find the correlation coefficient between size and defective quality, where the number of defective items are dependent on different total numbers of items, we shall now bring it down to a common number as 100, so that the number of defective items are calculated, recalculated, that is the percentage is calculated, and they are considered as the value of y. And then we shall proceed in the substitution of the formula. So we have now substituted the values in the formula that we already know, and we get the rho value to be negatively correlated, because rho is minus 0.9485, though it's closer to minus 1, it is negatively correlated. So that's the result that we infer based on the size and the number of defective items. We shall now take up some problems for a homework. I shall give you a few questions where you can try in similar manner. So let's see the next slide. These are some of the questions where the Karl Pearson's coefficients are required. So everything is straightforward. The method is not mentioned. The results are also given to you. You can cross check, and please let me know if the answers are correct. So you can use either the direct method or the actual mean method or the assumed mean method in order to get these answers. Two more questions. Calculate the Karl Pearson's coefficient of correlation for the following data using 44 and 26 respectively as the assumed mean of x and y. So normally we can assume any value as a and b, but here he has asked us in the question, he has given you the value of a and b to be 44 and 26 respectively. So that means we have to use the assumed mean method in order to simplify this particular problem. And the fifth one, as we did the fourth problem in the solved type, you are given the age and the number of unemployed, and he is now asking us to find the correlation coefficient between the mid values of the age group. So when you calculate the mid values between 20 to 30, it's becoming 25, 35, 45, etc. And the percentage of unemployed. So when I say percentage, please note the number of persons is given in thousands. So when I'm talking about percentage of unemployed, it will be 400 divided by the total number of persons, which you're talking about 40,000, multiplied by 100. So you're talking in thousands, so you need to assume multiply each of these terms by 1,000 and then calculate them. So I'm sure this will just become 1. 4 by 4 is 1. So the percentage there that you value, the values that you take for y have to be percentage of the unemployed, as we did in problem number 4. Kindly work out to check whether you get the value of rho as specified here as an answer. So these are the 5 questions for you to do as a homework. Now we shall meet with the next topic of next set of problems in my next video. So until then, kindly complete the task given to you. We shall meet very soon. Goodbye.